Good morning, students. Today is the lecture with series of differential equation. We are continuing with higher order linear differential equation. Last lecture, we had discussed about PI, particular integral of a differential equation. So we discussed some cases, special cases like cos x, cos a alpha x, sin alpha x, e to the power alpha x, and cos alpha x, sin alpha x, and x to the power m. And how to find the pi of a differential equation. Then we have already discussed about the CF. You know very well the complete solution of a differential equation is CF plus pi. Here CF is complementary function and pi is a particular integral. Now again we will here to solve some problem with specific on CF and pi. So after this practice session, the student will be able to conduct the exam very well and understand the method for find TI. So students, to be continue and we start a example and problem. Today we will start with a problem. Example d2y dx2 d2y dx2 plus dy dx plus sorry minus 2y is equal to x plus 5. Solution. First, we find out the CF. So, so here we make auxiliary equation. This plus 2 minus y x plus y. Now, auxiliary equation m square plus m minus 2. Here we find m square plus 2m minus m into 0. The root is m plus 2 factor minus 1 m minus 1 and is equal to 0 implies m is equal to 1 m is okay. These are the root of auxiliary equation and these are real and distinct. So the here is equal to c1 e to power x plus c2. Okay, this is the first case of. Now here. Here is equal to 1 upon d square plus d minus x plus cos. It becomes x d2 plus d minus plus cos x d2 plus d. Now, now this is the case of x to the power m, and this is the case of cos alpha x. So here we take minus 2 common, so this becomes 1 minus d square plus d plus cos alpha. Here alpha is equal to 1, so minus 1 cos square plus d minus. We know that 1 upon f d square cos alpha n we replace with minus alpha. Okay, but f minus alpha square not be should not be 0. Here minus half we take about 1 minus t plus t square upon 2 minus 1 x plus cos x upon t minus. Okay, d minus. Here we open the set minus 1 upon 1 plus d plus t square upon 2 and is square, so this may be greater than here m is equal to 1, so we open one time, expand it one time, and now d plus 3 d square by 9 cos x. For make t square we multiply both the term, uh, numerator and denominator, d plus 3. Now we take x inside, minus half x plus t plus d square upon 2 x plus d plus 3 minus 1 cos square. So here we get minus half x plus multiply 1 by 2 and d square x becomes 0. Actually we take inside x, multiply dx is equal to 1 and d square x is equal to 0. So d plus 3 minus square cos x, sorry, x multiplied cos x. Okay. Now, now we solve the differentiation of cos x. Okay. So here becomes here become like 1 by 2 plus x plus plus d equal to become d cos x plus 3 cos x. Okay. So minus half x minus 1 by 4 and d is equal to sin x minus sin x plus 3 cos x. Here we find minus x by 2 minus 1 by 4 plus sin x upon 10 minus 3 by 10. Now the complete solution here is equal to f plus c. F is equal to c1 e to power x x plus c2 upon e to power minus plus pi is equal to okay. So you can write c1 e to power x plus c2 e to power minus 2x plus minus x by 2 plus sin x cos x upon 10 minus this is the answer. You can see the student. You can note down. You can note down easily. First, I again repeat the question and procedure to solve the program. So here we see that the question given d2y on dx2. So we make auxiliary for equation m square plus m minus 2 is equal to 0. We factor this and find the roots. M is equal to 1, m is equal to minus 2. We usually factor this actually understand. Mhm. So, so here we find factor. These are the factors. Now, what is the out here? CF becomes C1 e to power x plus C2 e to power minus. This is called the CF. Now, part of PI. PI means particular. So, 1 upon d square plus d minus 2 x plus cos x. So, this becomes x. We segregate or separate the parts. Now, we make this in form of 1 minus z. Make 1 minus, so we take minus 1 by 2 as a common. Here, d square replaced by minus alpha square. Alpha is equal to here 1. So, minus 1 minus alpha square means minus 1 का square plus d minus 2. So, we get d minus 1. And here we expand it by, in this term, we expand it 1 minus z inverse is equal to 1 plus z plus z. Okay. So we write here expanded till z. What is the value of z? Z is the d plus d square upon. Okay. So we expand it here. We multiply with 1 plus x minus a, multiply with x plus a upon x. So become x plus a upon x square minus. That means the conjugate. Multiply with conjugate and open it. Open it, then become. Okay. Now we have done this question. Now a very interesting question is also we will do in this form. We, so I hope this question clear to all of you. Now second question. Now it's the class solution. Now we make auxiliary equation. Auxiliary equation become auxiliary equation become m square minus a square is equal to m is equal to plus minus. Okay. M square is equal to plus minus a. Now m is equal to become a and minus. Now the complementary function complementary function. Now the complementary function here. Actually I am write the full form of CS because sometimes in MCQ question he ask about the what is the full form of CS, what is the mean of CS, and student write complete function. This is not a complete function, it is complementary function. So remind when in MCQ I see many times a student tick on complete function. So you have to know the complete form of CS. Students, so I write here complementary function. So y is equal to yes, c1 e to power ax plus c2 e to power equation number. We find the half solution. Okay, but CF is the half solution of a problem. Now, here, a square minus a square is equal to, or we know that we know that cos hyperbola AX is equal to e to the power AX plus e to the power minus AX upon 2. So here we put the value e to the power AX plus e to the power minus AX. Okay, so here we can do 1 by 2 constant e to the power AX e square minus a square plus e to the power minus AX. Here we see when 1 upon d e to the power alpha is equal to e to the power alpha. Okay, so we do, but uh, f alpha should not be 0. But here you see when we put d, replace d as a, this is a, then it convert in 0, this is also a 0. So, so we apply 1 over. We multiply with x e to the power ax and then f dash equal 2 plus again x e to the power minus ax. Second case is f alpha is 0, then 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 e alpha f of f dash f. Now this becomes e to the power alpha f dash of Vihar alpha dash alpha should not be given. If this also 0, then we go to the further this process and we multiply again x and again differentiation. Okay, so here we get here we get 1 upon 2 1 by 2 differentiation of x e to the power alpha e to the power alpha x integration. These two we can take a common or we can write x integration of e to the power alpha x. Yeah, e to the power ax then become e. Similarly here x e to the power minus ax integration of e to the power minus alpha x e to the power minus ax then become e to the power ax upon minus. become minus a. So this is become minus. Okay. So here 1 upon 4, this we found e power x upon a plus x power minus ax upon, this will become 1 by 4 to x power ax upon a. Sorry, here is a plus, so it convert in minus. Sorry, this is a plus, this change in minus. Okay, plus, so it become 1 by 4 x upon a, we take common power ax minus power minus. Now we can write this as x upon 2a power ax minus power minus ax upon. This will be convert. We know that power ax minus power minus ax is equal to sine hyperbola. So we put here x upon 2a sine hyperbola. This is the now. Now the complete solution is y is equal to cf plus. Okay. So cf is equal to cf in my first term, equation 1, c1 power ax plus c2 power minus ax. C1 power ax plus c2 power minus ax plus x upon 2a sine hyperbola. This is the complete. Student, I told you that this is very important question also, because this is more confusing. This is very in series of higher differential order. We do that some important question. First, I told you that we'll discuss some important question in series. First, d square plus a square y is equal to tan ax or sec ax. This is very important question. Second, d square minus a square y or hyperbolic. Third, some question like d square d cube by dx cube plus 6 dy upon dx plus 9y. This type of question also has the importance. I could here we do that here dy upon. Okay, so this is here we have done x plus cos x. Similarly, we can find x square plus sin x. This type of question. And sometimes Here qx is x cos cos ax or cos n. So this is become the important question because there are two variables, two functions of x exist in Q. So I hope you very well clear how to attempt this question. Okay, here we learn today two example of differential equation. I again repeat this one. Let's see. We write the auxiliary equation, find the roots. Then roots are real and distinct. So we write like that. Now vi is equal to and cos hyperbola AX we can write this. We replace the value and become this. But here A is there minus A. When we put A, D is equal to A, it becomes 0. So we apply this method that ft is equal to 0, then we multiply with x and differentiate with respect to d. So we get here x upon 2d e to power a. Okay, or here x upon 2d dA. Now 1 upon d is the integration of e to power a. Here student remember that only we done the differentiation integration of e to power a, not x. X is the separate part. We are not use of x here. So it will become e to power ax upon a, x e to power minus x. And now we solve this equation. We get e to power ax minus e to power ax on 2. And this is called sine hyperbola. The complete solution is CF. Different. You can write down or write down here. This is the important. This is the important. So I hope कि आपको क्लियर हो गया होगा. This is the part wise PI. Now time for the quiz. And tomorrow we will take the lecture on active cosec. Next I will do the I will explain you this question x cos x and x plus sin. Because here we use the term x to the power n 1 upon. This is the answer. Okay. So I hope that method are helpful for you. Now we come to the Q. Two and five. Here PI. PI means particular integral. With the complete solution of differential equation, you easily can say that Pi is not a complete solution. Pi is the part of the solution. So this is false. Qx is equal to sec kx when general method applies. like to find p. Last time we find the general method that what is the general method? General method means we can write equation 1 upon d minus alpha we, and this convert in the linear differential equation of first order. The solution of first order is if I find out if. If is equal to integrating factor. Integrating factor will e power integration pdf. And p here as um, a, so it will become e to power ax. Now we apply y dot if is equal to integration qx I. So this will give you the general method and find k. I hope लास्ट लेक्चर में मैंने ये निकाला भी था इसका के एक्स पी आई कैसे निकालेंगे so try this method again and do the practice to find out the pi. Okay, CF is in hyperbolic form when the root of auxiliary equation are imaginary. No, this when the roots are imaginary, then we found cosec and sin x. Okay, now the root are radical, then we found an hyperbolic form. If the root are alpha plus beta under root beta form, alpha plus minus under root beta, then we write a cos under root beta x plus b sin under root beta. So, pi of e to the power 2x. Here we see that 1 upon d minus 2, d minus 2. When we put d as it to e to the power alpha x and alpha is equal to 2 and d replaced with alpha, then it becomes 0, fd becomes 0. So first we do the factor. So do the partial factor. So I have already told you about the partial fraction and we can write a upon d minus 2 plus b upon d minus 3. Then we find out the value of a and b constant and this 1 upon d minus 2 d minus 3 we can write down a upon d minus 2 plus b upon d minus 3 form. Okay, and then separate the terms. Find the pi of sin 2x if ft is equal to d minus. Find the pi. What method we are applying? Because here the method is sin alpha x cos alpha x. So here I can do it 1 upon d is equal to I do this 1 upon d minus 2. The function ft is equal to d minus 2. Pi is equal to become sin x upon d minus 2. Okay, so this is not d square form. For make the d square form we have multiply the d plus 2 numerator and denominator and we get sin 2. Now we put minus 2 square to become d plus 2 minus 2 square minus 4 sin 2x and this will become minus 1 upon 8 and d sin 2x plus 2 sin and this become 1 upon 8 and differentiation of a cos 2x plus 2 is constant plus 2 sin 2. This is the yes option. Okay. Now, the next question. Okay. The last question of is the root of equation of same and zero. Then CF. CF is C1 plus C2x e की power m. तो स्टूडेंट आई होप कि आप क्लियर हो गया होगा कि यू I hope that you clear about the section how to find the higher order equation solution. So next we will do uh, variable coefficient. Here all the coefficient of d2y dx2 dy dx are constant. But if the coefficient are in x form, then we call variable coefficient. And the solution of this type of equation, we convert the equation in the form of constant coefficient. So I hope in next step we will more aware about the CF and PI. Okay, thank you very much for listening.